Okay, it's fine. Let's start this session. So, in previous session, we have seen till here this point, till this section, right? Okay, fine. So over here we have seen what is facet grid. Agree, and we have understood how we can create a facet object, and then mention the type of scatter plot. Fine. So these are the ways. So we have seen how you can create a violin plot from the facet grid. Agree, and also how you can create a scatter plot using the facet grid. Okay, fine. So now in this session we are going to study. So if you see over here, so we are going to see this particular session now. Okay, the over here the multi-plot, join plot, and the pair plot. Okay, so as I already mentioned, pair plot is very important. So first of all, let's try to understand pair plot, and then we will see how what is pair grid and difference between pair plot and pair grid. Okay, so first of all, the meaning of pair plot is to draw the graph between each and every column with each and every other column from the complete given data set. So first of all, it will try to create pairs. Okay, so for example, if you have a column of c1, c2, c3, c4, fine, so it will draw graphs for each column with every other column. So it will make combinations like c1, c2, c2, c3, c1, c4. Okay, so these are the pairs, right? Then again, already c1, c2, c1 is done, so then c2, c3, c2, c4, then c3, c4. Okay, so it will consider one pair at a time, and it will try to provide us the graph. Okay, so that's the name pair. So as you can see over here, okay, so for example, if I just draw this, okay, let me let it run. And so here we are using the iris dataset. Okay, so I hope you remember the iris dataset where we have these four columns: sepal length, sepal width, petal length, petal width, and the categories are three: setosa, virginica, and versicolor. Okay, so this is a graph. So if I just save it, yes. So now, see here. Is this image visible?
Yes, sir.
Okay. So over here, if you see, we are the pair plot has done what? So it has considered all the rows on the x-axis. Okay. So first, let's just try to notice few things over here. So when you see so many graphs, so what's happening over here on the x-axis? If you see what are the graph columns, it has considered sepal length, sepal width, petal length, petal width. Four columns, and those are the only four columns available from our iris dataset. Agree? These are only four columns. It is considered. And in the pair plot, the same four columns will also be present on the y-axis also. So the columns on the x-axis will be same as the y-axis. Okay, the same columns. But now it will try to create pairs, okay, for each and every combination. So each of this block, every block over here represents one particular combination. Okay, so for example, if you see over here, this is a plot between petal length and sepal width. Agree? And this is a plot between sepal width and petal width. Okay, so this is sepal width and petal width. Okay, so like that, it has created graph between all the possible combinations. Okay, that is clear. First point. Now second point is there are few interesting things over here. So by default, okay, by default it will create a scatter plot. This, okay, so by default plot pair plot will create a scatter plot. Okay, so here you have mentioned hue equal to species, so that's why it is differentiating the given scatter plot based upon the species column. In species column, what do we have? So we have three things. One is setosa, virginica, and versicolor. These three type of categories we have as a flower names, right? So that you have given as a hue color coding. So that's why each and every scatter plot it has tried to differentiate with that particular color. Okay, but one more important thing over here is if you see All these are fine. Okay, all these are scatter plot. But if you see here, did you observe? So these graphs are different. Okay, so the diagonal graphs are different from the other graphs. But why is that so? Okay, here the point here is what is this graph between? Now, like what is this graph is between what two columns? Can someone tell me? Between which two columns this graph is representing?
Sepal width and sepal width.
Correct. So on x-axis we are having sepal width, and y-axis also we are having sepal width, right? So usually it draws scatter plot. Okay, this is scatter. Everything is scatter wherever you see this color. But along the diagonal line, what happens? Every diagonal line over here, you will have same column against its same column. Okay, so here sepal length. This is sepal length against sepal length. Okay, so this is sepal width again sepal width. Okay, so diagonal part you will have the same columns. Okay, against it itself. Fine. So over here, if you draw scatter plot, what happens? You will get straight line, this line, because on x-axis whatever the values you have, on y-axis also you have the same values. So when you draw, you will get a line like this, which is passing through the origin 45 degrees line, fine, which is equidistant from y-axis and also x-axis. You get that. Do you agree with me on this?
Yes.
Okay, then obviously there is no use from this, right? So because we don't want what is the scatter plot, okay, between a column against itself. Fine, we don't want it, because obviously we know if you use the same column c1 and c1 on x-axis and y-axis, obviously you will have a straight line passing through origin, so that is useless. Okay, so that's the reason only for diagonal columns it uses histogram. Okay, it uses histogram. Okay, histogram is a basically histogram is what? It's a univariate analysis. That means what? It will just give you the distribution of that particular column. At least that will be helpful instead of scatter plot. Okay, so that's why if you see over here, you are having the diagonal part. So this is the histogram of, this blue is the histogram of setosa. Okay, sepal length, sepal length and sepal length. That means wherever you are having setosa flowers, okay, output is setosa, it's corresponding all sepal length column, whatever you are having, right? So those data's histogram is this blue color. Okay, similarly for versicolor and virginica, and similarly for all. So for here, this blue is the histogram of petal width. Okay, only petal width for setosa. Okay, so when you filter the output on setosa, and when you consider only petal width column, it will have certain values, right? So if you take histogram of that, this blue color is that. Okay, and only for petal width, if you check for versicolor, this is the versicolor and this is virginica. Fine. So apart from this diagonal, everything will be scatter plot. Okay, every other plot is a scatter plot between x and y, because there will be two different columns that will be what to say, what that will be available. Okay, so petal length and this is sepal width. Okay, so this is between petal length and sepal width. Okay, that is second point. And third point is, once you have this diagonal, right, if you observe, the graphs above this diagonal are exactly same as graphs below this diagonal. Why? Because if you see over here, you are having, for example, over here you are having, what is this? This is sepal length and sepal width. Okay, this is sepal length and sepal width. Now what is this? This is also sepal width and sepal length. Okay, same, just the x and y are changing. Fine. So the graphs above the diagonal will be similar to the graphs below the diagonal. Okay, only the axis will be changing. Fine. So if you see, this is petal length and sepal width. Okay, and again over here, if you see, this is sepal length and, sorry, this is what, petal length sepal width, and here you have sepal length, sorry, petal length sepal width. Okay, this is also same. Okay, so the graph above this one and below will be same. Okay, above this, below this will be same. Fine. So 3 points. 1 point is, so for the pair point, so 1 point is usually draws all scatter plots. Okay, so all scatter plots except diagonal. Okay, second part is diagonal, you will get histograms. Okay, and third thing is graphs above diagonal are almost equal to, I mean, almost equal. Just the axis will be changing to below diagonal. Okay, is it clear, guys? Did you follow this? Any doubts?
No, sir. Follow.
Cool. So that is regarding the pair plot, guys, and it is very important because in one single diagram you can understand the correlation, or I mean, yeah, mostly the correlation between all columns possible combinations. Getting? So here, if you see, if you look at this graph, so here it is saying sepal width, petal length. Okay, so when you are having sepal width and petal length, fine. So when you consider only those, most of the time you can see setosa is getting separated. Agree? See here, you are having very clear separation of setosa. Okay, that means if you just consider, okay, in this graph, if you consider only this graph, this y-axis is petal length, right? So just if you say flowers which are having petal length less than 2.5, okay, that means this one will be setosa, because blue color is setosa. Agree? See here also there is, you get a clear segregation of setosa. See, fine. So you will get an idea like which particular columns are more helpful and which particular columns are less helpful. Fine. And then you'll also have some thoughts on what type of feature engineering you need to perform on what type of columns. That means here you don't need to work much on setosa because automatically it is getting separated most of the time. Fine. So but these versicolor and virginica are getting merged sometimes. Okay, but still it is not a clear merge, because still here it is getting separated. Till here you can see separation, till here you can see separation. Okay, but when compared to setosa, they are a bit closer. So then you can do some feature engineering things which we'll see in upcoming classes, like what conditions you need to put so that you can filter these two also. Fine. So those type of thoughts and ideas you will get based upon the pair plot. You will not do any code, you will not write a single line of code. Just if you generate this graph, by analyzing this graph, you can have very good information. And even this diagonal will also give you good information, right? So see here, the petal length, obviously, see, because the setosa is getting separated, so its distribution also a bit different from the other two graphs. See, setosa histogram is getting separated from others. Agree? So that's the reason mostly in the classification or regression, I mean, as of now you don't understand these words, but in mostly in the machine learning problems, so we generally generate this type of graph, okay, and try to analyze what is a mutual, you know, I would say the contributions between all the other columns. Okay, so is pair plot clear, guys? Do you understand?
Yes, sir. Clear.
So here you don't need to specify this hue. Hue, size, style. All these are just additional parameters, guys. So there is no rule you should specify. So if you don't specify, you will get just all blue. Fine. There will be no color coding sort of thing. Okay. So if you see, see, it's calculating graphs for every column against every other column. So the background, see. Okay. So it has given simple scatter plots between all columns, and the diagonal is histogram. Fine. So this is complete histogram of sepal length. Okay. So this is for all flowers. Okay. For all flowers, setosa, virginica, versicolor, all flowers included sepal length histogram. Okay. But when you add the hue parameter, so it will also segregate based upon different flowers. Okay. Fine. So that's regarding the pair plot. Now, continuing, we also have pair grid, guys. Okay. So as we have seen in today's morning session, so you can draw plots in two different ways. One is directly you can draw SNS dot while plot, and you can specify this column row, which we have done in previous sessions also. Okay, as I was showing, see, all these are facet plots. Okay, so directly you can draw, or you can also use facet grid, create a grid object, and then apply while plot from that grid object. Okay, both things are possible. Similarly, here also for pair plot also, one thing is you can directly use it from the SNS library, Seaborn library, or you can here also you can create a grid object. Okay, this grid is called pair grid. Okay, and then you can plot. Okay, here while creating the grid object, what I'm doing, SNS dot pair grid, I'm saying that means I want pair grid, and on this data, and this is my hue. Okay, that's all. And after that, using this object, I'm saying create a scatter plot. Okay, so now this is the thing, and as you can see, when you do directly, right, so it is also consider this will happen. See, when you're drawing sepal, this is between sepal length and sepal length, right? Sepal length and sepal length. So obviously, when you're using pair grid and using drawing the pair plot, so it is just considering scatter plot for each and every plot. Okay, so but when you specifically pick up pair plot, fine, so then the diagonals will be histograms. Okay, which is more helpful. And practically we generally use pair plots, I mean directly from the SNS. We don't create grid and draw. Okay, but knowing this should be helpful somewhere. Okay, so one difference is when you use direct pair grid, so it will just consider scatter plots for every plot. Okay, total how many plots we have? 16 plots we have. Okay, but over here everything will be same, only the diagonal will be histograms. Okay, fine. So after that, there are few additional parameters which you can control what type of graphs you can draw in this. Okay, so let's look them quickly. See here, I am creating a pair grid. Fine. So the advantage of creating the pair grid are we are going to see now. Okay, because when you use pair plot, so we are just drawing pair plot. That's it. We don't have any other. You cannot customize it. Okay, but when you use pair grid, so you can do many things. For example, when you see when I'm saying pair grid and using this G. Okay, so what I'm saying, observe here, I'm saying G dot map diag. Okay, that means in the diagonal what I want to draw. Okay, I'm saying draw box plot in the diagonal. Okay, that means this diagonal. Okay, so in the diagonal I don't want histogram, I want box plot. Okay, that you can mention using the grid, pair grid. Okay, so that I have mentioned. Okay, and off diagonal. Okay, that means apart from diagonal, other than diagonal, use KDE plot. Okay, I don't want scatter plot. Okay, by default it will be scatter plot. Okay, but if you want, you can also customize. So here I'm saying in diagonal go for box, other than diagonal go for KDE. Okay, so as you can see in the diagonal. Okay, so this diagonal is box plot. Okay, this is for sepal length box plot, sepal width box plot, right, like that. But apart from the diagonal, so all these, okay, all these are all KDE plots. Okay, so we have seen in morning session, we have seen, right? So KDE plot, how does KDE, and also if you remember, so these are drawing against two different columns. Okay, what is this KDE plot? For example, what is this KDE plot against? Okay, this KDE plot is against petal width and sepal length. Okay, two columns we are considering, so that becomes bivariate. Okay, morning we have seen it, bivariate KDE. Okay, so if I quickly show you, give me a second. Okay, so see, this is just single total will. This is for tip. Okay, when you combine X and Y. Okay, so this is a bivariate KDE plot. Okay, KDE plot. So similar thing is happening over here also. So off diagonal, that means apart from diagonal, every other column is having KDE plots. Okay, and since we have specified hue parameter, okay, it is also segregating. It is having 3 graphs for each of the species: Setosa, Virginica, versicolor, like that. Okay, so this blue is for only petal width, sepal length for Setosa, and like that. I hope you understand. Okay, so when you don't specify hue, okay, I'll also show you that. Okay, when you don't specify hue, the graph will be similar but without any color codings. Just give it a second. Okay, see. So these are all box plots in the diagram, and this is just sepal length and petal width. Okay, sorry, sepal width. Okay, sepal width and sepal length. Sepal length and sepal width. These two columns KDA, combined KDA. Okay, just like this. Oh, like this. Okay, but when you put the hue parameter, you also have its segregation between three different categories. Is this clear, guys? Did you guys follow?
So what will we know from these graphs? Like what information?
What information? Okay, see, individually you understand, right? So box plot, what does box plot say, right? We have studied in the box plot, right? So what does box plot say? So what is the 25th percentile? Like if there are any outliers, see, it looks like it is having some outliers, right? And then what is a comparison between sepal length and petal width medians, 58th percentile. So all this information what we have studied, the only difference is pair plot is not any new plot. It is just combination of different plots. But the only easy thing which it is giving it is doing at one shot. Okay. But what learning we are going to get is based upon the graphs itself. Okay. For example, petal length. If you see the petal length over here, fine. So this is minimum lower boundary. This is 25th percentile. This is 50th percentile, and this is 75th percentile, and this is upper boundary. Okay. So over here, if you see the median is very much nearer to the upper boundary. Agree? The median is very much nearer to the upper boundary. That means what? 50% of the values, okay, 50% of the values are less than this, what? Less than this median. Okay, less than this median. But this median is looking like it's a big value when compared to, for example, this sepal width. Okay, because the sepal width is somewhere around middle. Okay, it's somewhere around middle. Fine. But here the median is getting inclined towards the what? Inclined towards the upper boundary. Okay, that means maximum the value of the median. Okay, the value of the median is a little big value. That's what we can understand from this. Okay, because obviously when it is median, 50% of the values will be here. Okay, and 50% of the values will be here. Okay, but what are those possible values? Okay, what are those possible values? Over here, the values are going to be a bit high. Okay, because the median is shifted almost towards the 75th percentile. Okay, 75th percentile. Okay, the median is not in the exact middle. Fine. So it is moving towards the upper boundary. Fine. So those type of information you can understand. And regarding the other, this KDE plots, fine. So KDE plots from here, if you understand, if it is difficult for you to understand something, so you can follow with the simple, I would say this, where was that? Yeah, this histogram graph. Okay, because visualizing, understanding it from KDE plot might be different because we are usually habituated for the graphs to be in this shape. Okay, so for that purpose, you can use it as a histogram. Okay, but this is just a way, like you can use violin plots, everything. Okay, but still, if you want to use KDE, as we have discussed in the today's morning session, so wherever you are having this closeness, right, between the circles, so that means that frequency is high. Okay, what do I mean by that frequency is high? So that means sepal width over here, okay, sepal here over here could be somewhere around just 3. Okay, and petal width is 4. Okay, so the flowers whose sepal width is 3 and petal width equal to 4, those combination are having in are present in higher number. Okay, because here the graphs are, circles are coming closer and closer. Okay, and but it would be, for me practically, it would be the simple pair plot. Okay, with histograms by default, whatever, that will be more helpful. Okay, because just give me a second. Okay, because histograms are more easier to understand. So here I can clearly see its minimum value and it is maximum value. Okay, and after, and there is no overlapping between this graph and this graph. Okay, after its maximum value, the other graph, like versicolor minimum value is getting started. Okay, so that means just by looking at this, I can understand there is a clear separation between this setosa flowers and the other flowers. Okay, so that means what? I don't need to work more on the setosa. I can just put some condition, okay, mathematical condition, and just segregate setosa from other flowers. Okay, half of my problem is solved. Okay, what is the ultimate goal over here? If given these 4 values, sepal length, sepal width, petal length, petal width, I should be able to predict what type of flower it is. Okay, so just that means what? I should be able to segregate all of this based upon some conditions. Okay, if this value, if these are the values, then I should be able to tell 100% it is setosa. There is no other way it is going to be versicolor like that. That should be my goal. So by looking at this graph, it is, I think it is very much possible to segregate setosa at the first place. Okay, by putting some mathematical condition, as I said, like petal length is less than this value or petal width is greater than this value, so that it is definitely going to be, I don't need all other values. Just by one value or 2 values, I can just say if these values are less than or greater than this value, that flower is 100% going to be setosa. So half of my job is done. Right now, I just need to work on other 2. So what I'm going to do? So how I'm going to do all this from this graph itself? Fine. Otherwise, it will be without graphs also you can do, but it will be more. You need to put more efforts by looking at the values apart from graphs. Okay, but graphs will make you things easier. But as I said, these graphs are not new. Pair plot is not a new graph. Okay, it is just combination of different graphs. Okay, histogram you already know, scatter you already know, box you already know, KD you already know. You just put everything into one place. Is it clear? Did that answer your question, Meghna?
Yes, sir.
Okay, fine. So, and don't worry, how we are going to use, why we are going to use what type of graphs, you are going to see it in the EDA section. Okay, at that time it will be more clear, right? So when we take a use case, okay, for example, Iris dataset or Titan, like Titan dataset or some other toy dataset, when we take that and try to go step by step, there you will reach a particular stage called as EDA. So there it's called exploratory data analysis, where you will try to analyze what type of data, what type of columns these are. Okay, so then we are going to use different types of graphs, and then you will get a clarity like what type of graph should I use for what type of column, what type of problem. So why I'm using these graphs, what is the use of these graphs, what will happen if I don't use these graphs. All these questions will be answered more clearly. Okay, fine. So continuing ahead, so similarly, so the first thing we have over here is diagonal and off diagonal. So which means in diagonal there will be box plot, and apart from diagonal you have KD plot. Clear? And you can also have more options. So over here you are having G dot map diagonal. Okay, that means in the diagonal it should be histogram, and upper above diagonal is KD and below diagonal is scatter plot. Okay, simple. So that means in the diagonal part all these are histograms. Okay, and upper diagonal or KD, right? All these are KD. Okay, and below lower are scatter plot. Okay, all these are scatter plot. Right, so you can have different combinations. Why we are doing this? Because if at all it is just an example, but this whatever you're drawing, right? So it is an example, and this might not be that helpful for this type of data set, Iris, but this you can apply for any other data set. For example, there are some data set, okay, which you want to look both type of graphs. Why? Because why? If you just remember what I said, in 3 points, the graphs above diagonal are almost equal to below. Agree? The graphs above diagonal are equal to below because the same columns. Then what is the point of repeating the diagrams, repeating the plots? If I just look at only one side, it is, then I will also understand this side also, right? Then why to waste these plots? Agree? So we can use this for other kind of plots to understand the data set from some other dimension. So that's why we are using this. So in the diagonal, you are having the histogram. Okay, above you are below anyhow you scatter, because if you don't mention anything, obviously it is giving scatter like this. Okay, but when I already have scatter over here for the columns, I don't want to see them again over here. So that's why I'll go for some other plot. That's why he went for KD. Okay, you can go for box. Okay, so each graph will allow you to see the column from a new dimension. Box will speak about percentiles, outliers, etc. Agree? Histogram will speak about its distributions. If it is having only one, it is a unimodal or bimodal. Understand? This is unimodal, this is bimodal. Okay, and what is its distribution? What is its range? Okay, whether it is peaked or whether it is flat or whether it's uniform, etc., etc. Histogram will say that. And scatter plot will say what is the correlation, okay, whether it is having any positive correlation or negative correlation or any medium correlation or no correlation at all. Agree? So each graph is different from other graph, and it will try to give some other information from some other dimension. Agree? So it will be helpful to look at more number of graphs for the same data set. So that's why this histogram you are able to understand, and at below scatter plot you will get some idea. You will get, okay, some graphs are correlated and some columns are correlated and some are not. And here from KDE you will get some other information. Getting?
Yes, sir.
Okay, fine. So this is about diagonal upper and lower. Okay, and you also have one more same thing, diagonal upper and lower, but you also have one more parameter called as vars. Okay, that means variables. Okay, so instead of all these four, like sepal width, say all these four, you don't want all this. You just want only on based upon sepal width and petal width. Okay, then we'll consider only those two. Fine. So sepal width, petal width. Okay, and sepal width, petal width only based upon only these two I want to draw, and histogram in the diagonal, and upper is KD plot. This is KD. Okay, and lower is scatter plot. This is scatter plot. Okay, so because let's say you're having like 20 columns, okay, and if you just trigger this pair plot, it will make 20 into 20 combinations. Okay, so here you will have 20 into 20. How much? 400 graphs will get. Okay, I don't want all those, so then you can specify only specific columns which you want to see for the graphs. Cool. Okay.
Yes.
So now the last plot, so that is about the if I go above, so that's about the join plot. Sorry, that's about the pair plot. Okay, the last plot which you are going to study is a join plot. Okay, very simple plot. Okay, so let's quickly see it. So yeah, so here also in pair plot we have seen direct pair plot. Okay, what was that? Direct pair plot and also pair grid. Okay, pair grid. Fine. So, and when you say grid, you can also add some rows, columns like facet grid, etc. Okay, you can explore that. Now coming to join plot, and obviously we'll have join grid also. So first we'll try to understand join plot. So over here, when we're doing join plot, we're having data, okay, X and Y. Fine. Everything is same. Everything is same. Okay. See, this is join plot for total bill and tip. Okay. So here you have total bill and you are having your tip. Okay. And you have a scatter plot. Okay. This is scatter plot. But the only difference here is it will also draw histograms. Okay. It will also draw histograms along with this. Okay. So over here you have, okay, histogram of total bill. Okay. Over here you are having histogram of tip. Okay. So it is just one more way how they are giving graphs. You can think, so why we want this? Because we already have we already know how to draw histograms. We already know how to do how to draw scatter. Why we want to study this? That's acceptable, but there are different type of graphs. Okay, based upon your requirement and based upon your vision, you can pick and choose. Okay, but Seaborn is provided with different graphs. Okay, so it is always better to learn something which is famous and which is being used by many people. Okay, so that's the only concept of join plot. Okay, where it has a combination of scatter, okay, plus histo. Okay, on top of these graphs it will give the histograms of what are the columns you have considered. Fine, and this will be scatter. And yeah, so same thing over here. So when you do join plot, data equal tips, okay, scatter plot and tips hist. Okay, so in this join plot, what we are doing over here is I'm saying you on this data on this X and Y draw join plot. Okay, but instead of by default it uses scatter plot, right? So I'm saying no, use histogram. Okay, use histogram. Okay, and use the hue parameter as a 6. Fine. So when I do histogram and when I'm passing two columns, see total bill and tip. Okay, now this becomes bivariate histogram. Remember, this becomes bivariate because two columns are producing. If a single histogram will look like this, but bivariate will look like this. Okay, so if I show you from earlier session, so as you can see, this is a single total bill histogram and this is single tip histogram. Okay, but when you combine both total bill and tip, so this is how the histogram looks like. Okay, morning we have seen, right? So this particular thickness is having the majority of the so he's having the maximum frequency. That's why it's looking darker over here. Same thing is happening over here. So the total bill and tip. Okay, so you have some dark spots over here, and they're also color coded by hue parameter. Okay, and similarly the histograms are also drawn correspondingly, and these are also following the hue parameter. Okay, so only total bill. So this is for only total bill segregated with male and female, and this is only tip histogram segregated with male and female. Okay, but this is the combined bivariate histogram where it is having, where it is taking both the columns into consideration. Okay, fine. So that's about the joint plot. Fine. So these are, as I said, this is in similar to pair plot, nothing new plot. It is just a combination and permutation combination between other graphs. Okay, so by default scatter and histogram, or you can also change it to histogram and hue parameters. Okay, fine. So then you also have yeah, so then you can also draw something like this. So here I'm saying SNS dot joint grid. Okay, data tips X. Okay, this is joint grid. This is what? Joint grid object. Okay, on this grid object, I'm saying draw two graphs. Okay, one is KD plot, other thing is a y-line. So, okay, the first one is for the inside, and this y-line plot, the second parameter over here we specify it's for the on top of this graphs. Okay, so inside this you are having KD. So obviously when you're using two graphs, it becomes bivariate KD. Okay, this is bivariate KD, and when you say y-line, so it will also draw y-line plots for individual columns. Okay, this is total bill y-line plot. Okay, this is bar, this is KD again, and this is tip y-line plot. Okay, so as I said, joint is just combination of different graphs. Okay, what are we combining? So here you are having bivariate KD. Okay, here you have KD, and here the overall is called y-line. Okay, and inside this particular plot comes from box plot, and this outline graphs comes from KD. Fine. So it's just comparing different types of graphs, the pair plot or joint plot. Okay, same thing goes for this also for the total bill. Okay, so like that you can specify different type of, you can say bar plot, you can say scatter plot, you can say whatnot, swarm plot, all different sort of plots you can mention. Okay, so as I said, when you're learning the library, as of now we are not using it for a specific use case. Getting Megan and Sirisha, we are not using for a specific use case. We're just learning different graphs from the Seaborn. Okay, so now just observe it like that. Just understand what type of graphs are there, how to use that. Okay, just as a general knowledge from this library. When we are specifically considering a specific data set, okay, and let's say some agriculture data set, okay, or banking insurance data set, then specific to that data set, okay, just give me a second. Okay, so specific to that data set, we will understand what type of graphs we need to use. Okay, so it's not mandatory we are going to use all this. Okay, that based upon that data set does not require, let's say, scatter plot at all. It will only work, it will only have requirement of histogram. Okay, so then we will not use all these graphs at all. That we will understand when we are going for each use case point of view. Okay, but as of now, when you're learning library, you should learn everything. Okay, at least whatever that is required. Fine. So this is how you can draw a joint grid, but the format is same. Create a joint grid object and then use it as a plot. So, and this is for the inner and this for the outer. Fine. And if you don't want this, just you can go with the direct SNS or joint plot. If you don't want to create the grid. Is it clear, guys?
Yes, sir. Clear.
Cool. So that's about the Seaborn graphs, guys. Okay. Yeah, it was a lengthy sessions, I would say. Okay, and I hope we I'm sure we covered all the graphs that are famous in Seaborn, and I hope you are able to understand most of this. If not, go through them over the weekend. And if you know Matplotlib and Seaborn, and if you're comfortable with this, okay, trust me, most of the graphs you will not have any difficulty at all. Okay, any project you take, okay, any use case you take, you are not going to use any graph outside these graphs which we have discussed. Okay, these are more than enough, I would say. Fine. And just to add, there are like few interesting things about Seaborn. So if you see the dataset which we have used tips, we have used Iris, we have used Titanic, etc. Right? So those datasets, there are some datasets which are by default present in the SNS. Okay, so if you don't want to use the same dataset which I have used, okay, if you are bored with that, okay, so you can go for, you can use, and it's also very interesting for you to explore a new dataset, because this dataset I've already considered. So how you can dataset is sns.get dataset names. Okay, so it is saying all these datasets. See, we have used iris, we have used tips, we have used Titanic, but there are so many datasets which are unexplored. Fine, so you can take any one or two datasets and try to draw each and every plot which is discussed, scatter line. Okay, and that will be a very good exercise. And once you do that, you'll get an idea about, once you do, instead of listening to the class one, take some example, just load this. Okay, how to load? See, for example, see how I'll show you. See, this is right. So just take this way, and I just want to, for example, you tell me guys what type of data set you want to look at. Just pick one. You don't want to pick? Okay, fine. So I'll take, for example, planets. Okay, so I'll see data sets, planets, and when I see the planet, okay, see, these are the different variables in the planet. So it's a method, number, okay, orbital, period, mass, distance, year. So you have one categorical column and one and all these are numerical. Okay, so you're having some missing values. Okay, and this is integer, you're having these are decimals. Agree? So, and for example, you have penguins. Okay, see, this is also interesting. Fine, so species island. So take any one data set, try to apply all different set of graphs. Okay, and that should be more than enough for you to practice. Okay, so yeah, so this is thing about Seaborn. Okay, so fine guys, are we good? Any doubts?
No, sir, no doubts.
Okay, so fine, so that's all about the Seaborn. Okay, I'm going to send this notebook, and also and data sets, as I showed you, you can just load it from the SNS library itself. Okay, but I'm going to share this notebook. Okay, take some time and go through and try to practice these plots. Fine, so as mentioned, tomorrow we are going to start ML, okay, machine learning, and as I said, we are going to start it from the scratch. Okay, and it is going to be an interesting module. Fine, so come prepared. Okay, come with a fresh mindset. Okay, since you are going to study it at 0 level. Okay, fine, so that's all from my end. Okay, thanks for joining, and let's meet tomorrow. Okay, bye.
Sir, tomorrow class at 6:30.
Tomorrow 6:30, right? Okay, sure. Yeah, thanks for remaining. Chalo, bye guys.